Okay, question number 1 from UGC NET July 2015. This question says, how many strings of 5 digits have the property that the sum of their digit is 7? What does it mean? We have a number of 5 digits and the sum of their digits is 7. Okay, so we have to count such number of strings. For example, we have a string, sum of the digits is 7 and number of digits in this string is 5. Let's say we have this string. Okay, so this string is of 5 digits. Okay, 5 digit string and the sum of this string is 7. Sum of digits is 7. 1 plus 1, 2, 4, 6 and 7. So the sum should be 7 and the string should be of 5 digits. In how many ways we can do this? Okay, we have to count number of strings. So we can solve this question in two ways. Okay, so let's try to solve. The first attempt is easy attempt. If you know a little bit about counting, you are not aware of permutation and combination, then even then you can solve this question, but this will take a lot of time. Okay, the benefit of knowing permutation and combination is you can solve a lengthy question of counting in few seconds, or let's say 1 or 2 minutes. But if you do not know permutation and combination, then this question will take at least 15 minutes. Okay, if you do not know anything about permutation and combination. So how will you do this question? You will say, so I can take digits between 0 to 9. Okay, the problem with this is 9 is greater than 7, so I cannot take 9, I cannot take 8. Okay, I can take from 0 to 7. Okay, I can use this. So first string should be like this. Okay, we can form strings in this way. First string would be 0 0 0 0 7. Okay, 5 digit number and the sum of the numbers is 7. Okay, this is first one. Second can be like this, 6 1. Okay, 0 0 0, 6 1 7 and 0 7. So we have 5 digits and the sum of the strings is 7. This is acceptable. Third can be 5 2 000, or we can say 4 3 000, or we can say 4 2 1 000. 5 digits and the sum of the digits is 7. Okay, then we can say 4 1 1 1 and 0. 5 digits and the sum of the digit is 7. Or we can say 3 3 1 0 0. Okay, or we can say 3 2 2 0 0. The sum of the string is 7. Or we can form the string in such a way that 3 2 5 6 7. So sum of the string is 7. Sum of the digit is 7. Okay, or we can say 3 1 1 1. The 5 digit number and the sum of the digit is 7. Or we can write in this form 2 2 2 1 0. Sum of the digit is 7. Or we can write in this form 3 1 1 1 7. Or 2 2 1 0. This is the sum of the string is 7. Or we can say 2 2 1 1 1. So we can form the strings in these forms. Okay, so you can count like this. And now problem is this: we can arrange 7 in these 5 positions. Okay, we can put 7 here or here or here. What do I mean is, we can say 7 0 0. The sum of the digits is still 7, but we have changed the position of 7. So like this, we can change the position of 7 in 5 ways. Either we can put it here or here or here or here. So we can find the combination according to this. This is like a simple problem of arranging 5 balls in 5 places. Okay, from which 4 balls are same. Okay, so the formula for this is 5 factorial upon 4 factorial. Okay, this formula is coming from n factorial upon p factorial q factorial. Arranging n balls such that p balls are alike, q balls are alike. Okay, p balls are of same color, q balls are of same color. So this can be formed in 5 factorial upon 3 factorial. We can write for this 5 factorial upon 3 factorial, because 3 balls are same. 3 balls are same, 0, 0, 0. Or we can say like this, 5 factorial upon 3 factorial. Or we can write this one in 5 factorial upon 2 factorial ways. Why? 2 balls are alike. Or we can say this one, 3 balls are alike. 5 factorial upon 3 factorial. This will be 5 factorial upon 2 factorial and 2 factorial. 2 balls are alike, 2 balls are alike. So we can say 5 factorial upon 2 factorial into 2 factorial. Okay, we can write this. Or this one can be written like this, 5 factorial upon 2 factorial, 2 factorial. Like this you can write for everyone, and then you can you can find the sum of these. Okay, this will be 5 factorial upon 2 factorial. This will be 5 factorial upon 4 factorial. Why? 4 balls are alike. 3 balls are alike, which means 5 factorial upon 3 factorial. In this 4 balls are alike, we can say 5 factorial upon 4 factorial. In this 3 balls are alike, so we can say 5 factorial upon 3 factorial. Or we can say 5 factorial upon 2 factorial into 3 factorial. 2 balls are alike, 3 balls are alike. Okay, 5 factorial upon 2 factorial, 3 factorial. Now when you will find the sum of this, like you can find the sum 5 factorial upon 4 factorial, that is this one. Then you can write this 5 factorial upon 3 factorial. You have to count the such strings. Okay, so this will form a lot of strings, 5 into 4 into 3 into 2. Okay, this will form such strings. Okay, now from this we can only find 5 strings. Okay, when 7 will be here, then 7 will be here, 7 will be here, 7 will be here. Okay, 2 strings are these. Then we can say 0, 0, 7, 0, 0. Then we can say 0, 7, the triple 0. Or we can say 7 4 times 0. So 5 string will be there, because 5 factorial upon 4 factorial will be 5. Or we can say 5 factorial upon 3 factorial. Like this, when you will sum up them, the answer will be 330. Okay, this is the first approach. Or we can use a second approach, that is, the second approach will be, if you know probability very well, you know the counting, permutation, combination very well, then you will simply say the required number of string is required number of strings. This is the standard problem of finding the number of ways in which we can arrange n identical balls into k boxes. Okay, n identical balls into k boxes. Okay, so the required number of string is same as number of non-negative solutions of equation x1 plus x2 plus x3 plus x4 plus x5, okay, equals to 7. What does it mean? x1, x2, x3, x4, x5 are your digits. Okay, you can put anything here like this, 0, 1, 1, 0, 1, 1, then you can say 2 and 3. Okay, the sum of the digits is 7. x1 is 0, x2 is 1, x3 is 1, x4 is 2, x5 is 3. So we need to find the number of solutions such that the sum of x1 plus x2 plus x3 plus x4 plus x5 equals to 7. If we can find the number of solutions, we can simply count the number of ways in which we can find the sum of digits is 7. Okay, so this problem, now let's say you have this problem. Now you can, if you know the number of strings equals to number of non-negative solution of this equation, and this problem is same as, if you will observe this problem is same as the number of ways placing n identical balls into k boxes. Okay, you have n identical balls and identical balls are your digits 0 to 7. Okay, you have 0 to 7 digits and you have to place them into k boxes, that is 5 digits. Okay, you have 5 boxes and n identical balls. You have to put n balls into k boxes such that every box contains at least one ball. Okay, so n is digits which you can use to form the number 7. Okay, when you will place k boxes are this is 1 box, this is 2 box, this is 3 box, this is 4 box, this is 5th box. These are the boxes and you are placing 0 to n balls. You can place from 0 to 7. Okay, we have balls from ball number 0 to ball number 7. Now you have to place one of these balls to one of the boxes. So you can put 0 to 7 ball here and then 0 to 6 here. Like this, you can the number of ways placing an identical balls into k boxes is k plus, or you can say n plus k minus 1 c k minus 1. Okay, n plus k minus 1 k minus 1. K are the boxes and n are the identical balls. Okay, so we have n equals to 7 plus k equals to 5 minus 1 c 5 minus 1. So this will be 11 c4. So 11 c4 is 11 factorial upon n minus k factorial, that is 7 factorial into k factorial. Okay, 11 into 10 into 8 into 7 factorial, and like this 4 factorial into 7 factorial. 7 factorial will be this, and we have 11 into 10 into 9 into 8 upon 4 into 3 into 2. So this will be 11 into 30, that is 330. Okay, so in these ways we have 330. We can place n identical balls into k boxes into 330 ways, or we can say we can find the number of non-negative solution of this equation will be 330. Number of non-negative solutions of this equation will be 330, or we can say the required number of strings is 330. Okay, so second will be the answer.